Hey everyone! With this video, we are going to learn about how to find missing side lengths of right triangles using trigonometric ratios. The thing about using trig ratios to find a side length is that you can find one even if you only just have one of the three side lengths, where if you have two of them, you could use Pythagorean theorem, but if you only have one of them and one of the angle measures, you can use a trig ratio to find a side length. Take a second on your graphing calculator to make sure that it is set to degrees. So press the mode button near the top of your calculator and just look to make sure that degrees is selected instead of radians. This is always a good thing to check on before you start working on a trig problem. Okay, so in the first question, we need to find this side length of E. And when we look at where E is compared to the 48-degree angle, like where that is in relation to it, it's adjacent to it. It's next to the angle. And then the other side length that we have is the hypotenuse. So we're dealing with an adjacent and a hypotenuse. If you look up at our ratios up here, adjacent and hypotenuse is going to be a cosine. So this is how we set it up. Cosine of 48 degrees equals adjacent, which is E, over the hypotenuse, which is 67. Next, we need to go to our calculator to find out what is the cosine of 48 degrees. So on your home screen, just type in cosine, and then 48, end your parentheses, and see what you get. You should see 0.6691. We typically use 4 decimal places when we're dealing with trig ratios. So that's going to equal E over 67. And then from here, it's just solving it like a regular algebra problem. So we're going to multiply both sides by 67 so we can get E alone. Go back to your calculator and type that in. And we get that E is 44.8. All right, let's move on to the second one. So looking at the angle measure that we have, we can see that R is across from it or opposite, and then 7 again is our hypotenuse. So we're dealing with opposite and hypotenuse. If you look up here, that's going to be our sine ratio. So we have the sine of 17 degrees is going to equal opposite R over the hypotenuse of 7. Go to your calculator and find out what the sine of 17 degrees is. You should get 0.2924. That's equal to R over 7. And then again, we want to get R alone, so we multiply by 7 on both sides. And we get that R is 2.0. Okay, on to our third one. So 49 degrees, if we look at that angle, and we can see that V is opposite from the 49 degrees, that's the opposite leg, and then 42 is next to it or adjacent. So we're not using the hypotenuse this time, we're using opposite and adjacent, and if we look up at our ratios here, we're dealing with the tangent ratio. So we have the tangent of 49 degrees is opposite, which is V, over adjacent, which is 42. So go to your calculator, and just as a reminder, you can use Desmos on your computer to find the ratios as well. So you can, on the left-hand side of Desmos graphing, you can type in anything just like you would into a calculator. So you can type in tangent, or TAN, 49, and you will get the same exact answer you would get on your graphing calculator. So if you don't have your calculator with you or it's not working, just remember you can always use Desmos. So tangent of 49 degrees, that's 1.1504 equals V over 42. And then multiply by 42 on both sides to get V alone, and we get 48.3. And that's our V. Okay, we're going to do 2 more, and these are just going to be a little bit different just because of where the variable will end up in our ratio. So we have the angle of 26 degrees, and we notice that the opposite is 22, and then the hypotenuse is t. And so opposite and hypotenuse, that's SO or OH, which is sine, SOH. So sine of 26 is going to equal opposite over the hypotenuse. So this time our variable ended up in the denominator. Again, we need to go to our calculator or Desmos and type in the sine of 26 degrees, and that is 0.4384. And since our variable is in the denominator, we have a couple of options of how we want to approach this. You could, I think the easiest way is to treat it like a proportion and put it over 1, put the ratio over 1, and then just cross multiply. So we have 0.4384t is equal to 22, and then just solve for t by dividing by 0.4384 on both sides. So we get that t is equal to 50.2. All right, why don't you go ahead and try the next one by yourself. So pause the video and come back when you're done, and we'll see how you did. All right, well, welcome back. So this was a cosine ratio, since we had the adjacent was 48 and the hypotenuse was n. So hopefully you set it up as cosine of 19 equals 48 over n. And then by cross multiplying, we end up with our n value of 50.8. Great job. Okay, so here's another problem, and it's a little bit different because we know 2 of the side lengths instead of just 1. And so we can actually do this problem in a couple different ways. Okay, so we're going to start with our angle of 31 degrees, and we'll look at x, which we want to find, and we can see that that is our hypotenuse. And then we have 2 choices. We can either choose 12 or 20, and it doesn't matter. I'm just going to choose 12. So the 12 compared to the 31 degrees is across from it or the opposite. Since we have an opposite and a hypotenuse, that's going to be the sine ratio. So we could write down that the sine of 31 degrees is equal to the opposite, which is 12, over the hypotenuse, which is x. We could also think about this in another way, though. We could also use the 20. We could have used this in our work, and that's adjacent to the 31 degrees. It's right next to it. So another way of writing this is we could say that the cosine of 31 degrees is equal to the adjacent, which is 20, over the hypotenuse, which is x. So we have 2 different ways we could do this problem. We could use a sine ratio, and we can use the cosine ratio, and they're both going to give us the exact same answer. I want you to pause the video and work out these 2 problems by yourself, and hopefully you get the same answer, and then come back in a little bit and check in with me and see how you did. Okay, welcome back. How did you do? Did you get 23.3 for both of them? If you didn't, go ahead and check through my steps and see if you can find where you might have made a mistake. There's actually a third way we could even have solved this problem. We didn't even have to use trig ratios because we had 2 sides of a right triangle. We could have even used the Pythagorean theorem. Let's go ahead and just try that way and just see how it comes out. So if we had done a squared plus b squared equals c squared, the 2 legs that are given to us are a and b. So we have 12 squared plus 20 squared equals c squared. That's 144 plus 400. And then that's 544 equals c squared. Finally, let's take the square root of both sides, and we get that c is about equal to 23.3. So you really only have to use trig ratios if you only know one of the side lengths. If you know 2, you can use the Pythagorean theorem. But it's nice to know that you have different options and different ways of checking yourself to see that you're doing it right. This next question is a little bit different because we have all 3 angle measures, and none of them are marked as our reference angle. So we can choose either angle W or angle V to use as our reference angle. We want to find WU. Let's go ahead and label that X. If we use V as our reference angle, and we see that X is opposite or across from that, and 10, the other side that we know, is next to it or adjacent, we have an opposite and we have an adjacent, which is going to be tangent. So we can write this down as the tangent of 34 degrees is going to be equal to the opposite, which is our x, over the adjacent, which is 10. Now, we could have also done this in a different way. We could have used W as our reference angle, and we notice that across from that, or opposite, is 10, and then X is adjacent to it. So it's still tangent, it's just going to be a little bit different. So we would say that the tangent of 56 degrees this time is equal to the opposite, which is 10 over X. So they look really similar, but we have two different degree measures, and one has X over 10, and one has 10 over X. You can do it either way. Go ahead and write at least one of them down and solve it on your own. Pause the video and come back and then see how you did. Okay, hopefully you got 6.7 doing one of the two ways. If you happen to try both ways, you got the same answer, both different ways you could do it. Okay, now we have sort of an application problem. Here is a 15-foot ladder leaning against a wall. The angle formed by the ladder and the ground is 80 degrees. And we want to find out how far is the base of the ladder from the wall. So we're basically looking for this down here. That's going to be our x. And from the 80-degree angle, the x is next to it or adjacent. And the number that we know is 15, which is the hypotenuse. So adjacent and hypotenuse, that's going to give us a cosine. So we have cosine of 80 degrees is going to equal x over 15. Go ahead and pause the video and solve that for x and come back and check in a second. Okay, hopefully you got 2.6 feet. All right, for the second one, we want to know how far up the wall does the ladder reach. So this time we're looking for this height here. And compared to the 80 degrees, that's our opposite. And again, with the hypotenuse of 15, we have opposite hypotenuse, which is a sine ratio. So we do the sine of 80 degrees is going to equal opposite, which is h in this case, over the hypotenuse of 15. Again, go ahead and pause the video, work it out yourself, and come back and check and see how you did. Okay, so hopefully you got 14.8 feet, and that's how high up the wall the ladder went. All right, for this last question, we're going to need to draw a picture to see what's going on, and we have a ladder leaning against a wall. So here, sort of the wall and the floor, and there's our ladder. And the angle with the ground is 63 degrees. And we want to know how far up the wall the ladder will reach. And it's 2 meters from the wall right now. I'm going to let you set it up all by yourself this time, figure out which ratio you need, set it up, and solve it, and then come back and check and see how you did. So pause the video, don't cheat, do it by yourself, and come back and check it in a minute. Okay, I got 3.9 feet, and I hope you did too. Let me know if you have any questions. You can email me with questions or stop by at Sting tomorrow, and I'll get you straightened out. Have a great day.